positive charges of magnitude q are placed at the ends of a side 1 of a square of side 2a. Two negative charges of same magnitude are kept at the other corners. Starting from which, if the charge q moves from the middle of side 1 to the center of a square, its kinetic energy at the center of a square is. Okay, so we have a square here. So this is our square. It is said that 2-point charge of magnitude q are placed at the ends of side 1 of a square of side 2. So we have two charges that is kept here. This is here, and two positive charges of equal magnitude are placed at the ends. So this is q and q. The square of side 2a. So this is the square of side 2a. Two negative charges of same magnitude are kept at the other corner. So this is minus q, and this is here minus q. Starting from rest, if the charge q moves from the middle of side 1 of the center of the square, it is saying that starting from rest, if a charge q moves from the middle of the side 1 of the center of a square, middle of the side 1 to the center of a square, its kinetic energy at the center of a square is. So basically the charge is initially here, and then this charge is moving from this position to this position here up to here. So charge is moving from here to here. Then we have to find its kinetic energy at the center of the square. So let's say this is the charge q here, and this is the center. So let's say this is initial point, and this is the final. So I will say that change in potential energy will be equals to gain in kinetic energy. Total change in potential energy will be equals to gain in kinetic energy, because total energy is conserved. So, or I can also write in other format. If I want to write, I will conserve the energy, and then I will write here kinetic energy initial plus potential energy initial equals to kinetic energy final plus potential energy final. So kinetic energy initial starting from rest is 0. Potential energy initial for this position is how much? So due to this q, if you calculate, due to this q, potential energy at here will be k q q by a. Due to this one also here, that will be k q q by a. Due to this one, if you calculate this distance is how much? So this is nothing but root of 5a, because this is a and this is 2a. So this will be minus of k q q by root 5a minus of k q q by root 5a. And potential energy we got. Kinetic energy final that we have to calculate, that is half mv square, but they are asking us simply to write the kinetic energy. So no problem, we can directly write this in terms of k only, kinetic energy. So let us consider this as a k here, and then it is saying potential energy at the center. So you can see that whatever the potential energy here we have due to this positive at this position, and then this positive at this position, exactly same amount of potential energy we will have negative at this position, and because of this negative also same value. So I can say that total potential at the center because of all these four charges is how much here? 0. So if I write, then this will become k times k plus 0. So if you simplify it, kinetic energy k, kinetic energy ke, kinetic energy ke will be how much? That will be k q q k q q by a, let's take common, and 2 also. This will be 1 minus 1 by root of 5. So this is option 1. Here correct option is option 1.